Hello students, welcome back. We are now at day 4 of our unit 2, which is Earth's internal structures. We kind of began, we finished the layers on page 4. We finished the oceanic crust, continental crust, right? We should have the layered drawing on page 3 of our notebooks now. And now we're continuing from pages 5 and 6 and going to page 7, So let me go and let me just grab my notebook here, just to be sure we're all on the same page and we've all got the notebook, because we have a notebook quiz on Friday. We've got another unit quiz on Friday, and these are important for those, right? So yes. Okay, so let's continue, guys. Again, page 5 was yesterday's Go Blue, and page 6 was the seismic waves notes. Seismic waves, that was the beginning of our earthquake stuff, which we didn't quite finish yet. We finished on focus and epicenter. And that's what we finished on. So we should have that at the bottom of page 6 right now. Other than that, there's no other updates, guys. We've got the vocab due Friday. Get that turned in. No need to worry about the lab, because we can't actually do the lab at all in our e-learning class. So maybe some alternative assignment. I did, if you guys didn't see already, I did post a workbook assignment. I'm currently looking to scan those workbook pages onto Canvas and then scan the textbook pages that you will need to answer those workbook pages on your own. So again, I'll give you those separately to print out and from there, okay? Now, let's go ahead, guys. Number 1, what are the 2 parts of an earthquake and how are they different? And then 2, what are the 2 major causes of earthquakes? We mentioned this yesterday. Again, this should be on page 6 of your notes already. Again, we're taking Go Blue on page 7. Pause the video, think about it. Let's move on. Okay, our answers for number 1, as we stated previously, 2 parts are the focus and the epicenter, right? The focus, and people miss this on test all the time, so be sure you know these, right? The focus is where the earthquake happens underground. It's where the plates actually slip in the ground. The epicenter is not in the ground, it's gonna be at the surface. The epicenter is where the earthquake happens at the surface. Go ahead and write that for your question answers on page 7. Page 7, again, just to repeat and kind of re-solidify those ideas. Number 2, what is the cause of earthquakes? There's 2 main causes. We've got, like I said before, the tectonic plate slip, right? And then also, think of Hawaii here, volcanic eruptions. Volcanic eruptions are going to be a big cause for earthquakes in general, right? It's why the West Coast has so many earthquakes, because we have those volcanoes in Hawaii. We have those fault lines in California, et cetera. So again, for number 2, tectonic plate slipping and volcanic eruptions. Make sure to pause the video and record those as you see fit. And let's move on. Table of contents is not new. We've still got pages 5 through 8, seismic waves. Again, we are now on page 7 for our Go Blue. We've added seismic wave notes to page 6. So if we happen to add more seismic wave stuff, you may need to move it to page 8. I was just thinking there for a second. Sorry, guys. Again, here's our vocabulary, guys. As we know, this is going to be due Friday. You only need to do 1 through 13. You need to give me a definition. You need to give me an example sentence. Those are 2 separate things. And the illustration, or also known as the doodle. You turn this in for 13. With the first 13, you get an A. If you do the 16 of them, you get extra credit. If you only do the sentence and the definition, you get a B. So make sure you get an A. You get all of that done. Moving on, we're going to skip that. Card question. Again, we can't access the Plickr card questions, so we'll go ahead and skip that as well. Do go ahead on page 5, though. I'd like you to write down these 2 questions, these 2 topics, and they're just 1 or 2 word answers. Number 1. When one tectonic plate goes below another, what do we call that? It is called a what? Blank. And number 2, tectonic plate slipping in the ocean, not on the land, when it happens in the ocean, we call that a what? Call that a what? Pause the video, write those down on page 5. The video link will be on Canvas for you guys under sample videos when you go below the main lesson video. Okay? Please answer those on your own and watch that video. I'm going to go ahead right now and show you a short sample. Really good video here from National Geographic.
Ground starts to quiver. Glasses rattle. Soon, walls shift and everything begins to collapse. Telltale signs of what could be a devastating earthquake. We've seen the destruction they unleash. Some of us may have even lived through one. And we know they can be deadly. But where does this mountain-moving force come from? While we may think we're standing on solid ground, the Earth beneath us isn't completely stable at all. Our planet's crust is made up of about 12 major tectonic plates.
So here are those plates, right? And if you're low, now Florida doesn't get as many because we're away from the lines, but when you're close to these fault lines, those are all places where you're going to likely see a lot of earthquakes, right?
That fit together like a...
And look, here we have Japan. I mean, we got 1, 2, 3, 4, we got 4 fault lines all intersecting all around Japan, so a lot there.
Giant jigsaw puzzle. These huge slabs of land float on superheated magma and constantly shift, bump, and grind against one another.
And shortly after this, you will find the answer to our first question. What do we call it when one plate goes below another? What's that called? And then secondly, when an earthquake or when plates slip in the ocean, what does that cause? You need to watch the rest of that video to get those answers on your own as well. Moving on. Nope. Anyways, so go ahead. We're now going to be on still page 6. This is going to be on page 6. Just write what's in red here. Okay? So what's an earthquake? It's when one tectonic plate movement releases energy. The pressure that is built up breaks, resulting in seismic waves. So our plate's always moving, kind of. It's very slow and very steady. But when an earthquake happens, we're talking about a major movement. We're talking about a very quick, fast, sudden movement, right? So, again, the plates are moving, okay? We have continents moving 1 inch a year, 2.5 centimeters a year. Very slow, very steady, you don't even feel it. But when earthquakes happen, it's a sudden movement. It's when enough pressure is built up that it just slips fast, right? Okay, no need to write this down. This is just for discussion's sake, okay? Now, how common do you think earthquakes are in Florida and why? First, ask yourself, as someone who's probably lived in Florida most of the time. Has an earthquake, have you ever experienced an earthquake? Most of us will say no. Why? Because earthquakes are not common in Florida, guys. They're not common at all. Why? Because we're not near a fault line. Here at the bottom of this sheet, I have, at the bottom of this slide, we can see all the areas where we get a lot of earthquakes. It's all along the West Coast. States like Montana, California, Oregon, Washington, Alaska. Alaska's actually the #1 earthquake state in the U.S. California's second. And then Hawaii's in there. Again, Hawaii has volcanoes, right? Now, why doesn't Florida get them? Because if you guys look here, Florida is not touching or nowhere near a fault line. Most of the fault lines run along the Central America West Coast. And we see some of the Caribbean here with the Dominican Republic and Cuba, right? So that's where you're going to see those, okay? Our next thing we're going to add to page 6 is what are seismic waves. We know what they are, but we need to make sure we've written this down, guys. Seismic waves are the waves of energy caused by sudden breaking of rock in earth or explosion. So simply put, they're the sound waves that come out of the earth, but we call them seismic waves. Super, super important is this next sentence here. Recorded on seismographs. Again, recorded on seismographs. Seismographs are the tools you see maybe in the movie San Andreas with the rock, right? That read earthquakes and the earth movement, and they make the squiggly lines, right? We'll see more examples of those probably tomorrow. So again, recorded on seismographs, okay? We're gonna go ahead and skip this video, no need to worry about that. We're gonna do these video questions tomorrow, no need to worry about that. Again, these are a bunch of silly memes about earthquakes. I really don't mention them too much, but hopefully if you guys don't know, this is what's called an etch and sketch, okay? One of the best items you could have as a kid in the 90s. I think some of you students who were born in 2000s obviously know what I'm talking about. It's like you turn the knobs and you make a drawing and then you shake it and then it erases the drawing. So pretty cool. If you don't know what an etch and sketch is, definitely check it out, check videos out of it. It's a pretty cool thing. All right, last thing we're gonna write for the day is what's here in yellow. This is gonna be on page 8. I repeat, we are now on page 8, and the title of page 8, as you see here, is gonna be types of seismic waves. Title page 8, title page 8, types of seismic waves. We're now going to talk about the different types of waves that earthquakes give off. You're going to learn about 3. We're going to learn about 3, okay? Again, we'll do this video tomorrow. Do not worry about it. We'll do this video tomorrow. All right, for today, last thing we're going to write for the day. The 2 types of waves you need to know about. Again, include the title and include these 2 sections and the bullet points. Are P primary waves and S secondary waves. So P and S are for short. For the long version, they're called primary and secondary waves, okay? What do you need to know about the primary waves? Primary waves are going to be the first wave that hits in an earthquake. It's the very first initial shake, the first initial wave that hits in an earthquake, okay? They are also known as longitudinal waves. Again, the other name for these, the alternate name is longitudinal waves. Have that down, okay? They can pass through both solids and liquids. Basically, P waves can go through because they're just a straight line. They go through the entire Earth. They go through all the layers. Again, all the layers are either a solid or a liquid. There's only one layer in the Earth that is not a solid. It is a liquid. That is a what? That is the outer core, okay? And again, P waves arrive first. Thus, we now know that they are the fastest. Okay, let's talk about secondary waves. Kind of the opposite, okay? They're also known, instead of longitudinal, they're known as transverse waves. Again, not just they're called transverse waves. They kind of move like an S shape. I'm going to show you a video of the slinky movement, a GIF of the slinky in a second. Okay, the slinky demonstrates these different waves. S waves, super important to know. Super important. Can only travel through solids. They cannot travel through liquids. Think about that. If they can't travel through liquids, then what layer can't they travel through? The outer core. Outer core is the only layer on Earth that is a liquid. Can't travel through the outer core. Okay? And secondly, if they're called secondary waves, I wonder why. Well, it's because they arrive second in the wave patterns of earthquakes. So again, S waves are second. They're also known as transverse. They can't go through liquids, only solids. Okay? So they can't go through. They can't go through the outer core. Can't go through the outer core. Okay? So let's take a look at some of these here. All right? Again, a P wave, as you see in this GIF here, it's going to be a straightforward movement. It's going to go right through, just from point A to Z, A to Z. Okay? The S wave is going to be kind of up and down, like an S, right? The S wave is going to go up and down like an S. Now, if we had a slinky, I could show you guys in class the appearance of this difference, okay? The top, we have the S wave, also known as the transverse wave. Again, here it's moving up and down, up and down. The P wave is straightforward. It's A to Z, one thing to the next. Again, also known as longitudinal waves, okay? Students, that concludes our stuff for today. All right? We'll have more practice, more questions and such as we move along. Oh, give me 1 second. I have a student.
No, I was online. You sure? Yeah, it's recording. Okay. Yeah. Oh, actually, it's recording right now. Okay. Okay, I'm gonna stop recording.
All right, students. Well, that concludes our lesson for today. I have a quick meeting, so I will get to you guys tomorrow. If you have questions, let me know on Canvas, and we will continue our earthquake notes tomorrow. Have a great day. See you 1 second.